Hey PCWorld fans, Adam Patrick Murray here with Gordon Ma-ung,
Hey.
our resident CPU expert, and we're here to talk about Threadripper 2. Right?
And there, I'm going to correct you first. It's second generation Threadripper. I know we all want to call it Threadripper 2.
Man.
It is easier to call it that.
You've been going over all the numbers this week, really going in some in-depth testing. So you want to show me some charts and
definitely.
and go over that. But before we do that, why don't we talk about what we actually have?
We got 4 new CPUs. I'm going to be like that car salesman here. You got 4 new CPUs. Not all of them available immediately, but on the bottom end, 2920X, 12 cores, $649, 3.5 gigahertz base, 4.3 gigahertz boost. One step up is the 16-core 2950X that replaces last year's 1950X. $899, $100 cheaper. 3.5 gigahertz base, 4.4 boost.
Okay, sounds good so far.
One more notch up is the new 2970WX. W means work, all work, no play. Adam knows about that. 24 cores, 48 threads, 3 gigahertz base, 4.2 gigahertz turbo, $1299. And of course, the chip everybody wants to know about is the earth-shattering second generation Ryzen Threadripper, using its full name because that's what you got to do. 2990WX, 32 cores, 64 threads, 3 gigahertz base, 4.2 gigahertz boost, $1799.
Okay, well,
that's all 4 of them. The only one that you can pre-order right now is a 2990WX. The other ones are coming later. The 16-core, end of August, and the 24 and 12-core parts in October.
Okay, awesome. So the one we're going to focus on today is that 32-core beast.
Yes.
Because that's the one that's coming out first. So.
I think that's the one I'm most excited about because, we've seen a, 8, 12, and 16-core Threadripper. So I want to see what you get. This, again, is a big deal. It's the first 32-core consumer CPU that AMD is selling. There's a couple big differences between last year's 1950X and this next slide shows you. This is the new 2950X. It's improved. Still 16 cores, but all kinds of the goodness that we saw in the second generation Ryzen, desktop parts, the Ryzen 7 CPU, higher clocks, lower latency. In Threadripper, it has 2 8-core CPUs. You can see they both on this chart. They each have a DDR4 memory controller. They each have PCIe. That's how they get to 64 PCIe lanes. Okay. And you have those 2 gray blobs. No CPU die in this Threadripper for the 16-core part. But on the 32-core part, you get all 4 of those, right?
Nice.
Remember, for people who think it is just an EPYC, everybody says, oh, it's just a relabeled EPYC. It isn't. It is actually quite different because an EPYC has 8 channels of DDR4. This has 4 channels of DDR4. Okay. EPYC has PCIe hot on all the dies. Threadripper does not. So it is actually wired quite differently internally. And because you have only 2 CPUs with DDR4 memory controller and PCIe, the other 2 dies that bring you all the way to 32 cores, they have to talk through those other 2 CPUs if they want to get to memory or if they want to get to PCIe. So they are compute-only dies, only CPU dies. They are still connected through the super fast Infinity Fabric. In this case, AMD says you get about 25 gigs bandwidth bidirectional from die to die. Compare that to the 16-core version, which is 50 gigs of die-to-die, because you probably don't have all the wires running between them, so you've got to now dedicate some of that to make sure these CPUs can talk to each other.
So is that going to be a problem?
I don't know. I would think in theory it could be an issue. There's, here in the slide itself, you can see that near memory, so the dies that actually have the memory controller in them, the latency is 64 nanoseconds. For the die that's further out that has to speak through that, it has to go, hey, I need to talk to memory. It goes through that controller. It's about 105 nanoseconds. So there is a real latency penalty. I don't know where that's going to affect you in actual performance, though, and we'll try to see if it shows up. I'm not sure I'm seeing it anywhere yet, but
What else is new about this this new architecture?
So of course, the new Ryzen Master, AMD's utility that lets you turn stuff off and tweak things. This Ryzen Master on the 32-core part lets you go from 32 cores and they realize not everybody needs 32 cores all the time. You can actually switch off half of it. So you can turn off those 2 compute dies, go down to 16 cores.
And that's called legacy mode?
Legacy mode or game mode. Game mode, I think, kicks you into that. It's also called legacy mode. And that's for some games that just freak out. There's some games that just will freak out if you threw last year's 16 core at them. They're not even going to run on this one with 64 threads. So AMD lets you tune it down. It lets you go from 64 or 32 down to 16 or even down to 8. You can actually just turn on one CPU die, effectively turning it into a Ryzen 7. You have to reboot in order to go into reboot. You do have to reboot to go into legacy mode. So and the next slide actually shows you. So right now, Ryzen Master is in gaming mode, and you can see those 3 other dies are just reading the newspaper. The last one's doing all the work. So, and I want to include this chart or this one graphic for people who have never seen this. Windows, if you have 64 threads, doesn't really know what to do that. You no longer get that little squiggly line of load, and it's just simply percent load on the CPU at that time.
This looks pretty funny.
This is what it looks like. This is cool.
This looks pretty fun.
It's fun, right? It's neat to see in Windows with that many threads.
All right, now let's get into the charts.
Into charts. First up, I'm going to do all the feel-good stuff. This CPU is made for professional pixel pushers. Right?
Okay.
First up, Cinebench R15, multi-threaded performance, and you can see at the very top of that chart, Threadripper 2990WX just kicking all kinds of butt and taking names. It's taking everybody's names. We're seeing a score of 5,182. The previous fastest CPU was the skylake-x 18-core part, that Core i9 with 3393. This is 5,182. It's like 50 to 60% faster sometimes. That's basically 50%.
That's a large jump.
It's a big jump in performance. This thing cooks when you throw the right workloads at it. Like Pavre. Pavre is a ray tracer, goes all the way back to the days of the Amiga. Very much loves threads, and look at that 2990WX, 64 threads, all over everybody at like 10,041. Wow. 18 core down there at a 6,500. It's all kinds of good. Again, professional pixel pushers. That's good stuff. Same thing in Blender. We're not seeing quite the same amount of scaling, but damn, it just is wailing on everybody. Again, no kidding, 64 threads, 32 cores, greater than 18 and 36.
Yeah, makes sense.
You're getting what you paid for if you do this kind of work. Corona Renderer, photorealistic renderer, almost 12 million in their standalone benchmark. Jeez. Pretty damn good. A 6-core Coffee Lake X is 3.5 million. So 18-core Core i9 at 8.6 million. So a lot of performance, V-Ray render. This is actually a popular renderer being used in a lot of movies. It was actually used in some scenes in Deadpool.
Okay.
Captain America Civil War.
Nice.
And Doctor Strange. So this is realistic. You are going to get way more performance. 26 seconds to complete the CPU render versus 37 seconds for that 18-core skylake-x part.
It's better.
It's better. Shorter bar.
It's got more
less
cores.
time means you can do other things. You can go do more work. Then you get more work done.
Yeah, but what about single-threaded tasks?
Single-threaded tasks. Now we're going to run this because the vast majority of the world is not multi-threaded. Not everybody's going to be supporting a 64-thread CPU. So once you go to single-threaded, it flips over. Previously, it was all AMD. Now it's all Intel. In fact, the top part is that Core i7 8700K. 6 cores, run at higher clocks. 206 in single-thread performance in Cinebench. Intel is firmly in charge of those single-threaded benchmarks. That turbo performance out of those skylake-x and even KB Lake is well ahead of everybody. We don't even see an AMD part show up until number 7, the Ryzen 7 2700X at 179, and our 32-core part is 172, which is good.
Yeah,
still, I mean, it's not bad. It's a good performance. Yeah. But you know what? For single-thread performance, Intel rules the day, and they have ruled the day. I mean, they have a lead there, and and it's not just Cinebench. In Pavre, same thing. Pavre has a single-threaded benchmark. Hey, not a surprise. Core i7 8700K, number 1 again.
Okay.
And then KB Lake, skylake-x, 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 KB Lake. Again, we don't see an AMD part show up until number 7 with the Ryzen Threadripper. pretty good though. 419.
It's not too far off.
Not too far off,
still,
but if you're looking for single-threaded performance, it's all about Intel. It has been about Intel. People got to admit that. Word, Excel,
Photoshop.
Chrome, Photoshop. Frankly, a lot of people think it's multi-threaded. It ain't. It ain't. So you're going to get the best performance out of those high IPC, high clock parts. This though is a little bit is going to bug some people.
Okay.
And it probably should. This is Handbrake. It's an older version. We just take a 30 gig file. We transcode it from 1080p MKV to Android tablet to make it smaller from 30 gigs down to 1 or 2 gigs. It is generally very multi-threaded, and the more cores you throw at it, it generally ends up the fastest.
Yeah, but
for example,
that's not here though.
Well, so the fastest part is that skylake-x part, 796, right?
Yeah.
And then we actually don't see the 32 core Threadripper until number 5.
Wait, but so if you said Handbrake needs more cores, then what's that doing down at number 5?
So that is possible. What is going on? I think is it? I don't know. Is it that is it memory bandwidth? Is it the die-to-die latency? Is it because Handbrake really just doesn't support more than X amount of cores? I've never really seen it top out, but apparently we are topped out. Is it because we are running Handbrake on this, which may use 18 or 20 threads or 30 threads, which pulls that 32-core, 64-thread CPU out of those higher boost clocks to a lower clock. So it's now running at a lower clock speed because it's just enough to depress overall clock speeds, but not enough to take advantage of all those other threads that are just sitting there doing nothing because Handbrake doesn't support it. It's not really clear to me.
Interesting.
It could be a lot of these different things, but yeah, not a good showing. Again, this is sort of the messaging AMD is saying. They're saying, we got this 32-core part. It's awesomeness for people who do 3D professionally. If you're, again, professional pixel pusher. If you're doing video editor, like you're doing encoding, maybe you should get a 16-core. We got our brand new Ryzen Threadripper 2950X, 16 cores, higher clocks, lower latency. Great part. Buy that instead.
Okay.
That is actually a good message here. That you're sort of seeing that.
Well, speaking of Premiere.
Yeah. So again, this is we take Premiere Pro Creative Cloud 2018, the latest version. We take an actual project that Dan shot on Sony Alpha in 4K, and then we export it from within Premiere using the Blu-ray preset, 1080p, and then I check max render, because when you change resolution, you do want actually to check max render for the scaling. And we're also running this on the CPU. This is not a GPU load here. This is actually on the CPU. And again, skylake-x with 18 cores, interestingly, is faster by a good margin over that 32-core 2990X.
And that's because you think Adobe is not scaling properly?
Yeah, there could be other things, who knows, but I do think it again is Premiere doesn't use 64 threads of compute that are threaded. Video encoders I've not seen really they don't scale as well as what we saw earlier, all those 3D renderers, Corona, Cinebench, V-Ray, all those things, they scale like a mother. A lot of video encoders I'm not seeing really scale that highly. So it may not be the best choice to go for a 32-core chip necessarily, but wait, watch the whole video. Don't just click off now. Watch the whole video. We're going to get into other situations where it might help. So another thing, this is just 7-zip. This is an older version. AMD's own numbers actually put them ahead. This older version that I'm running and the chip that I'm running is actually slightly behind the 18-core part. Not exactly sure why that is. A decent showing. It is right there with that skylake-x part, but definitely not where you would hope a 32-core CPU would be doing against an 18-core CPU.
Because once again, maybe 7-zip doesn't have
it
support for all those threads?
Could be 7-zip. It could be that die-to-die latency. I'm not exactly sure what it is. But of course, at the end of the day, if the 7-zip benchmark is worth anything indicative of its own performance, you're going to get better performance out of these other chips. Obviously, the first two chips are those Core i9s with higher clocks, but that Threadripper 1950X, not bad either. Unfortunately, I didn't get a chance to fire up the 16-core 2950X. I'm going to do it afterwards. I think it's going to represent really well. I think it'll actually pull within that 16-core skylake-x.
Oh, okay.
Because what we've seen, the second gen Ryzen 7 is a big performance boost over their first ones. A lot of things were just fixed. I really think that second gen 16 core is going to be a better part for a lot of these more pedestrian workstation tasks. If you could ever call doing those kind of things pedestrian. But again, another one that is really just a head scratcher. This is Veracrypt, and it's just simply the built-in benchmark. I actually started using this because AMD threw this out as a benchmark, I think, with Ryzen, the first Ryzen launch. And it's like, okay, this is the benchmark that you're saying we should run for CPUs.
Sure.
Well, what is going on here? Because that 32-core Ryzen Threadripper is off, not great score. And then also I'm noticing what I recorded for the 16-core skylake-x, not great either. So I don't know what the hell is going on here, frankly.
That's weird.
There's just a lot of kind of weirdness that you get to some of these multi-threaded benchmarks. You just don't know what exactly is going on here. So I'm going to withhold judgment on this because it's really weird that we have two high core count parts that are running lower in performance, but they clearly are. I went in and I actually was like, this doesn't make any sense. Maybe I did it wrong. As a benchmark, you always go, I must have screwed up. I went in and I reran this multiple times, same performance. And then I went ahead and it's like, well, let's see if it's latency. So I kicked it into legacy mode, into half mode, and quarter mode. Didn't make any difference.
Weird.
This is just, I was just simply getting 15 out of the Veracrypt benchmark. I don't know why that is.
So far the story is that whoever is going to need the 32 cores is 3D renders, right?
Yeah.
If you're doing more single core stuff, Intel's got it. Until you
Right.
get into simultaneous tasks. So yeah, let's
Yeah.
go over that because this is, I think, where it gets really, really interesting.
Yeah, because I really at my heart think it's just because it's very hard to find applications that use all those threads. Let's try doing multiple things at once. So what I did is I took the exact same Premiere Pro encode that I did earlier, where we saw the 18-core skylake-x whoop the 32-core Threadripper, and then I decided, well, let's throw Blender in there. And of course, this is actually very realistic because Premiere is a popular video editor, NLE, for people doing projects. And Blender is a very popular 3D renderer and modeler for people doing indie films. So like you're an indie filmmaker and you're actually making your own indie film and you're rendering out an effect in Blender and you're encoding, that's actually very realistic.
Yeah, it makes sense.
So in this situation, when we do this, we now see, of course, it was already faster in Blender. Still, again, healthy performance out of Threadripper over the Core i9. And before, where the Core i9 was definitely much faster than the 32-core Threadripper, it is now slower.
Yeah, that's not the case anymore.
Not the case because we are throwing a lot more work at the 18-core part, and the 32-core part definitely can handle it. It just shakes it off. It's like not even a big deal.
Wow.
I got to say, you might actually do this if you had a 64-thread CPU, because I can do it,
might as
right?
well, yeah.
Why not? I can get more done. It means I can get my project done faster. Previously, I've been exporting from within Premiere directly, which is, I think a lot of sort of hobbyists will do that. I do it. Professionals like Adam, they use Adobe Media Encoder, which I believe is the old main concept engine. Yep. And what I did is I took Media Encoder and I said, let's encode multiple formats at the same time. Now,
from one project.
From one project. So I took the same, minute and a half to 2 minute video that Dan shot, 4K alpha, and then I exported it simultaneously to Blu-ray, HEVC, YouTube, and Vimeo. I think the HEVC and the Vimeo were both 4K, and Blu-ray of 1080p and YouTube were 1080p.
Okay.
Max Render was checked off on Blu-ray and YouTube, and when you're doing that,
wow.
Yeah, Zen is back in front again,
Threadripper's
right?
better.
So it's better when you're doing this load. Although, again, I've got to say, I thought it would be even faster.
It's really, actually not that much faster, but I mean, it's still the opposite of just the single encode.
Right. Before that, 18 core is just smoking the 32 core, and now the 32 core is definitely beaten up on the 18 core. And I got to say, I think if I took Media Encoder and said, well, you know what, I'm also going to encode out to like Facebook and maybe 3 other, video codecs, I think we'll see that gap. I think you give that Threadripper more work and it'll actually be faster. It's the weirdest thing. It's like the more work you can give it, the faster it gets, of course, right? If you're giving it really light loads, it's not going to be really fast. But if you're just slamming it with all kinds of crazy loads, and again, this may sound crazy, but Adam actually does this. He encodes multiple videos, right? Media Encoder.
Multiple quality versions for posting to different places.
This one is crazy, though. So I decided, let's really throw something nuts at it. Let's run Blender. which is heavily multi-threaded, and let's run Cinebench, which is heavily multi-threaded. So this
at the same time.
At the same time, it's actually very good. I've run this multiple times. It's actually the run-to-run variation is very minimal. It is actually very difficult when you do multitasking to try to get the results to be the same. They generally recommend that you bind each thread to each core physically. You can actually do that within Windows. I don't bother to do that because most people are just never going to do that. It's just simply you click the go button. So when I did that, look at the performance. So of course Blender Threadripper was already faster before, still faster here by 40 seconds, which is a very good amount. What, 30%, 35% faster? And then look at that Cinebench score. The 18-core Skylake part is 278.
Which before, when we were just doing a single bench score, it was beating Threadripper.
Right.
And now it's slowed all the way down where Threadripper is able to maintain itself.
And the crazy part is the score from the Threadripper while simultaneously running Blender and Cinebench is actually faster than the Core i9 18-core part just running Cinebench by itself. Right? That's just crazy.
That's crazy.
Now, this is not probably realistic. I doubt people are running 2 different 3D rendering products at the same time. It's possible, I suppose, but I think that's probably like the outer edge.
Well, but the point is that where this really shines is doing multitasking. You're able to not have to, let something encode and walk away and go get some coffee. You're able to still continue to do something. And that's where it shines.
Yeah, I mean, that's just crazy. But, you have to go to these almost extreme examples.
Yeah.
But, for professionals, it's probably not that extreme. And I do want to run in games. First, the message is don't buy 32-core Threadripper for gaming. Don't buy it for gaming, don't buy it for gaming, don't buy it for gaming. That's the messaging from AMD.
Okay.
They're saying we got this Ryzen 7. Of course, Intel's saying, hey, we got these Core i7 and Core i9. Doesn't matter. You're buying the wrong tool for the wrong job, but you still want to see the performance. So I did run a couple games. I just want to at least see how it performs because people want to know. If it's a weakness, you got to know, right?
Yeah, you got to know.
But you don't buy a 32-core CPU to play Fortnite. You just don't. You shouldn't.
No.
I wouldn't recommend it. But Rainbow Six Siege, I ran this with our GTX 1080. Same NVIDIA drivers in both machines. This is current build of Windows.
Okay.
skylake-x, very good performance. Intel's always really good at gaming, even on that Core i9 part. 220 frames a second. Threadripper, when you have all the cores hot, not great, right? We're down at 173, 32 cores. I mean, it's not going to kill you, but it's kind of like, that's like 50 frames a second difference.
Yeah.
The good news is you kick that into legacy mode, which is, we're basically turning into a Ryzen 7, and we're up at 215 frames a second on the Threadripper.
Which is pretty much right there with the Core.
It's pretty much within the margin of error, and at that point, you're not unhappy. This is 1080p Ultra on Rainbow Six Siege. I think if we ran at a very low game quality setting, the i9 may be even more faster, but for the most part, it's not a big deal. But again, I don't recommend that you buy a Core i9 just for gaming, and I don't recommend you buy a 2990 WX just for gaming.
Okay.
And again, just so we can prove the point, Rise of the Tomb Raider, 1080p, very high setting, DX12 mode, same thing, 2990X, 32 cores, all hot, not great. And we're seeing, again, 40 frame difference between a Core i9, but you flip on legacy mode and we're basically dead even.
Yeah.
So no big deal. But again, don't buy an $1,800 CPU to play video games unless you're rich and you just want to show off. That's cool. That's cool. It's your money. But I wouldn't do it. Let's also look at memory bandwidth. There's some little details people are going to want to see of the chip. This is running 8064 memory, read, write, copy, all combined into one. I ran it Threadripper in full, legacy, and then at half, and then legacy quarter mode. No surprise, bandwidth pretty decent, about 90 gigs a second. Once you go into legacy mode and you turn off 3 out of 4 dies and you go into dual channel mode, 42 gigs a second. So, it is what it is. You're not going to get the best memory bandwidth, but you probably don't need it for those applications down there. So.
Okay. And
also latency. I wanted to try to see if I could get to that die-to-die latency. Early on, we talked about that memory latency, that that issue where you have a CPU without any memory controller having to talk to one with memory out to the memory.
Okay.
AMD's own numbers say it does add latency. I tried to find out, so I ran 8 to 64 memory latency on it in full, which is all 32 cores. At 16 and 8, and I was hoping to see some increase. I would have expected maybe worse memory latency with all 32 cores hot. I didn't actually see it, so that may be a good sign. It may also be because 8 to 64 doesn't actually use those outer dies that don't have the memory controller. So,
okay.
you know, we're still trying to dig into it. I don't think it's a big deal, but, you know, people do want to know if that kind of layout's going to be an impact or not.
We'll keep an eye on it.
Yeah, no, so far I'm not seeing anything really alarming. So, and of course, I love this chart because this is where I take Cinebench. I love it because it takes like an hour and a half to run. I run Cinebench, and you can actually select how many threads you want to use. So I run it from 1 thread to the maximum threads of the CPU. So 1 to 64, which takes a long time. I'm running them sequentially, so there is a little bit of performance bump from caching. It's a little hard to read because there's just so many little tiny bars on this chart. But basically, the left side of the chart sort of indicates what you would get if you were running those lightly threaded apps, you know, video encoding by itself, gaming, Photoshop, you know, Chrome, Word. A lot of those, you know, applications are like 1, maybe 3, maybe 4 threads. Some of the earlier multi-threaded benchmarks or multi-threaded applications, they only use 4 threads. So you really don't get all. So on the left side of the chart, it's all about Intel. It's all about Intel. That Core i9, the 18-core part with the high turbo clocks, they're just pushing really high clock speeds, and that just gives them that edge over the 2990WX because higher clocks, generally for the most part, both CPUs are almost equal in efficiency, pretty damn close. So with the higher clocks of the Intel part, that's where they have their edge. And if you're doing what a lot of people do, it may make sense to buy a lighter CPU, smaller CPU with fewer cores. That's what this chart tells you.
Okay.
Intel, of course, would say buy our Core i9 7980XE for $2,000. AMD would say, hey, we got this Ryzen Threadripper 2950X. Hey, it's $70.99. You can take that over $1,200 and build a whole new machine, or buy a 2 terabyte SSD and a video card if you wanted to. That's AMD's message. But clearly, 18-core Core i9, all over those light thread loads. Of course, it's crazy to think of up to 26 threads as a light thread, but all that kind of like everywhere down, it's all about a Core i9. On the right side of this chart, it's all about those cores. And this is a little harder. Again, you can see in the blue, it's just much, much higher. This next chart I'm going to show you, we break it down by percent increase and decrease. You can see them. You can see
this is
here.
a little better to read.
A little easier to read. Left side, Core, it's a messaging from Intel on Core i9. Hey, we're giving you all the magic up to 26 threads. We are just, look, they're up to 25% faster than that 32 core part in, you know, like 18 threads. All over it. Higher clock speeds. They're just cooking along. It's just cooking. And these messaging is like, hey, you're pushing pixels, 26 threads on up, we rule. And they really rule because look, you just start stepping up and going and going and going. By the time we get to 64 threads, we're up over 50 to 55% more performance, which we saw validated in, you know, Corona. We saw it in V-Ray. We saw it in POV-Ray. It's just 32 greater than 18 is the basic messaging. And the crazy thing, though, is the right side is like, I mean, you're making your own cinematic movie at home for the Marvel Universe. That's where you want to be. It's like, okay. And this, like, it's crazy to think that up to 24 threads is a light load these days. But we're kind of getting there. And, of course, the last thing, this is the money shot, and it's literally the money shot. This is where we take the list price of the CPUs, and I compute how much they cost per thread. And there were some errors last time we did in the podcast. This one I've updated. Look at that. It's insane, but Ryzen Threadripper is just a stupidly good deal.
It is. Wow.
$27 per thread for the 12-core Threadripper 2nd gen. $27 for the 24-core Threadripper. And if you're going to pay $1 more, folks, $1 more
per thread.
Per thread, you can get a 32-core or 16-core Threadripper 2nd gen part. I mean, $28 for a 32-core 64-thread CPU per thread. Of course, you got to buy 64 of them, so it's $1,800.
It's a deal.
It's a deal, but still, it's a crazy deal because look, Intel, like the 18-core current, you know, top end, Core i9, Core i9 7980 XE, 18 cores, 36 threads, $55 a thread versus 27.
That's double the price per thread.
It's double the price per thread, right? I go into theater, I want the big size. Don't give me it's only a quarter more. Give that to me, right? I just and also for comparison, I did throw in the current 28 core Intel part. A lot of people suspect that was the CPU they used in Computex to demo. A lot of people think that's what they're going to introduce in this year. Nobody really knows. Intel knows. But that is a Xeon Platinum 8176, 28 cores, 56 threads, $156 per thread.
Now, I'm not good at math, but that doesn't seem like a good deal.
Not a good deal. Well, but look, it's $8,700, I think, for that CPU. But to be fair, people, I know they want to make fun of that Xeon. That Xeon will go on a machine that supports up to 8 CPUs. So it supports up to 8-way configurations.
Okay.
You know what? I'll tell you, it's the people who are building 8-way servers, they don't care. Whatever, $8,000 CPU, that's like nothing. We'll burn that, and so they don't even care. So that they can get 8 28-core CPUs in a server is what they're paying for. That's not even a big deal. But for consumers, $28 per thread.
That's not bad.
That is not bad, and that is a huge breakthrough, right? This is just all good if you can use it.
Yeah.
Right?
You got to be able to use it. That's where it makes sense.
And I got to say, I love it. It's just awesome. A lot of this is also developers need to catch up. I, in my heart, think Microsoft Windows can't really handle 64 threads. I think there's some efficiency that can be picked up from the OS too. In my heart, I say so. AMD will never say that because they never say mean things about their partners, but I think Microsoft probably could improve performance because we're in the world where a consumer has a 32-core CPU. Here's the insane thing. When Intel came out with the Core i7 6950X for $1,723, you got 10 cores.
Yes.
AMD is saying for $76 more than that original Broadwell E part, 10 core, we'll give you 32 cores.
Wow.
So it's all kinds of good. But again, if you're at home, you're watching this, and you're going to go back and play Fortnite, don't buy the CPU. Go buy a Ryzen, go buy a Core i7, buy a Core i5. That's where you should be doing. If you're going to go back and say, yeah, I got this great gig. I work for Sanford & Son Rendering, and I got a project for the new MCU movie, then that's what you want because you want those cores.
Well, you've been really nose in the sand for doing all this testing. So thank you, Gordon. I think we all appreciate it. Thank you for taking us through the benchmarks because everybody loves charts.
Everybody loves them.
So next up, you will be looking at the other parts and kind of doing the tests on those because testing never stops.
Testing never starts. I think that 2950X could be the sweet spot. $800, 16 cores, 32 threads. Higher clocks, lower latency. I mean, looking at all the numbers here, because I just re-reviewed all the 2700X numbers, it was a very impressive CPU.
Yeah,
very impressive.
Definitely.
And if 2950X gets that sort of same bump, and there's no reason not to assume it won't, it's going to be the CPU that I think, I play games and I'm streaming. That could be the perfect CPU for you, for me, for a lot of people. But again, like I was saying, this CPU is perfect for Sanford & Son Rendering Company, working for Marvel Cinematic Universe, or somebody just needs crazy amounts of cores. So.
Awesome. Well, so keep an eye on YouTube for future reference to those videos, and PCWorld.com to see the full review and all the charts as they appear. So
more charts.
Yeah, yes. more charts, and more charts. So all right, cool. Thank you, Gordon.